5,000 years ago, in the river valleys of what is now southern Iraq, a civilization emerged that would quietly lay the foundation for something humanity would not fully understand until the 21st century. They did not call it artificial intelligence. They had no word for algorithms, no concept of machine learning, and no idea that future civilizations would spend trillions of dollars trying to replicate what they had already built by hand in clay. The Sumerians created a system that processed information, recognized patterns, made predictions, and automated the distribution of knowledge across an entire civilization. And when you examine how that system actually worked, the comparison to modern artificial intelligence is not a metaphor. It is an observation. This is the story of the world's first information processing civilization, and the question it raises about where intelligence really begins. If you find ancient history as fascinating as we do, subscribe before you keep watching. To understand what the Sumerians built, you first need to understand what the world looked like before they arrived. For most of human prehistory, knowledge was oral. Communities passed down information through stories, songs, and direct instruction. One person taught another person, who taught someone else, and the chain continued. This worked reasonably well for small groups living in relatively simple conditions, but it had a fundamental limitation. In every piece of knowledge was only as permanent as the human being who carried it. If the elder, who knew the medicinal properties of a particular plant, died before passing that knowledge on, it was gone. If the trader who remembered last year's grain prices moved away, the data went with him. Human memory was the only storage medium available, and human memory, as we all understand, is fragile, inconsistent, and subject to decay. The Sumerians confronted this problem as their civilization grew too large and too complex to function on memory alone. By around 3,500 BC, the city of Uruk had grown into one of the largest urban centers in the ancient world, with a population that some historians estimate reached 50,000 people. Managing a city of that size required tracking enormous quantities of resources, coordinating labor across hundreds of different trades, enforcing agreements between parties who might never meet again, and making decisions about allocation and distribution that affected thousands of lives. There was no way a single human mind, or even a group of human minds, could hold all of that information simultaneously and process it reliably. So the Sumerians did something that no civilization before them had ever done. They built a system to do it for them. The cuneiform tablet is one of the most recognizable symbols of ancient Mesopotamia. A small rectangle of clay pressed with a reed stylus to create wedge-shaped marks that recorded everything from grain inventories to legal contracts to astronomical observations. Archaeologists have recovered more than 500,000 of these tablets from sites across the ancient Near East. And when you examine them, not as historical artifacts, but as information architecture, a very different picture emerges. The earliest tablets, dating from around 3400 BC, were not literary texts. They were not prayers or myths or royal proclamations. They were accounting records. They tracked quantities of grain, numbers of livestock, allocations of labor, and transfers of goods between warehouses and individuals. And the way this information was structured was not arbitrary. It followed a consistent, deliberate format that allowed anyone trained in the system to read, interpret, and act on the data without requiring additional explanation. But this is what computer scientists and data engineers refer to as structured data, information organized according to a predetermined schema so that it can be stored, retrieved, and processed efficiently. Every tablet followed a recognizable pattern. Every symbol had a fixed meaning. Every entry occupied a predictable position within the record. The system was designed not for human storytelling, but for machine-like processing. The Sumerians even developed a standardized unit system to make their data interoperable. Weights, volumes, lengths, and quantities were all converted into common units before being recorded, which meant that information from one city's granary could be directly compared with information from another city's granary without any translation or interpretation. The data was clean, consistent, and ready to be computed. When you look at a Sumerian administrative tablet from this perspective, what you are actually looking at is a database entry. The clay is the storage medium, the cuneiform symbols are the encoding scheme, and the temple scribes who maintained the records were functioning, in a very real sense, as the processing layer of a system that was larger than any individual within it. Recording information is one thing, but the Sumerians went considerably further than that. They also developed rule-based systems for making decisions, and the logic embedded in those systems bears a striking resemblance to what computer scientists today call conditional programming. Modern software is built on a foundation of conditional logic. If a certain condition is true, the system takes one action. If it is false, the system takes a different action. These if-then rules can be nested, combined, and layered to handle increasingly complex situations. And at sufficient scale, they begin to produce behavior that looks remarkably like intelligent decision-making. The Sumerians wrote these rules in clay. The law code of Ur-Nammu, dating from approximately 2100 BC, and widely regarded as the oldest surviving legal code in human history, is structured almost entirely as a series of conditional statements. If a man commits a certain offense, then the penalty is a specific restitution. If a slave escapes and is captured, then the captor receives a specified reward. If a field is flooded by a neighbor's negligence, then the damage is calculated and compensated according to a fixed formula. These were not guidelines open to interpretation. They were executable rules, designed to produce consistent outputs from variable inputs, which is precisely how rule-based AI systems work. A modern expert system, one of the earliest and most foundational forms of artificial intelligence, operates on exactly this principle. Take in a set of conditions, match them against a database of rules, and output the appropriate decision. The Sumerians did not need a computer to build an expert system. They needed clay, scribes, and a civilization complex enough to require one. And by the 3rd millennium BC, they had all three. The legal codes were just the most visible layer. Similar rule-based logic governed agricultural decisions, such as when to irrigate and how to rotate crops based on observable soil conditions. It governed trade, with fixed exchange rates that removed the need for negotiation on routine transactions. It governed temple administration with hierarchical allocation formulas that determined how grain and oil were distributed to different classes of workers. Every time a scribe applied one of these rules, they were executing a function in a system that processed real-world inputs and generated standardized outputs. One of the defining capabilities of modern AI is pattern recognition, the ability to analyze large amounts of historical data and identify regularities that allow for reliable prediction of future events. This is how weather forecasting algorithms work, how financial models detect market trends, and how medical diagnostic systems identify disease. And it is also, remarkably, how Sumerian astronomers approached the night sky. As the Babylonian astronomical tradition, which grew directly out of earlier Sumerian observation practices, was built on the systematic recording and analysis of celestial events over periods of decades and centuries. Scribes tracked the positions of planets, the timing of lunar eclipses, the rising and setting of Venus, and dozens of other astronomical phenomena, recording each observation in a standardized format on clay tablets known as astronomical diaries. Over generations, patterns emerged from this accumulated data. The Saros cycle, a period of approximately 18 years and 11 days, after which lunar eclipses repeat in the same sequence, was identified through careful analysis of long-term observational records. The synodic periods of the visible planets, meaning the time it takes each planet to complete one cycle relative to Earth as seen from the ground, were calculated with accuracy that modern astronomers have confirmed to within fractions of a percent. These were not lucky guesses or inspired revelations. They were the product of a systematic process that would be immediately recognizable to any modern data scientist. Collect observations, standardize the format, accumulate a large enough dataset, look for recurring patterns, and use those patterns to generate predictions that can be tested against future observations. The Sumerians and their Babylonian successors were running prediction models on astronomical data, and the outputs of those models were accurate enough to be useful for centuries after they were first generated. The same pattern recognition approach was applied to agriculture, where scribes tracked flood levels, rainfall, and harvest yields across multiple years, and used that data to inform decisions about planting cycles and resource allocation. It was applied to medicine, where symptom observation tablets recorded associations between physical signs and likely outcomes in a format that functioned as a diagnostic lookup system. The method was consistent because the underlying logic was consistent. Data in, pattern identified, prediction generated. Perhaps the most significant parallel between Sumerian information systems and modern AI is not any single function, but the broader project they both represent, which is the attempt to automate knowledge itself. Automation, in its most fundamental sense, means encoding a process in such a way that it can be executed reliably without requiring the full attention and judgment of a skilled human being every time it runs. A mill automates the grinding of grain. A loom automates the weaving of cloth. The Sumerians automated knowledge, and the implications of that were just as far-reaching as any mechanical invention. Before the Sumerian writing system, calculating the area of an irregularly shaped field required a skilled mathematician who could hold the problem in his head and work through it from first principles. After the development of mathematical tablets, any trained scribe could perform the same calculation by following a documented procedure. The knowledge did not live in the expert anymore. It lived in the clay. And because it lived in the clay, it could be copied, distributed, taught, and executed across the entire civilization simultaneously. The Sumerians created what we would today call knowledge bases, curated repositories of documented procedures, reference tables, and decision rules that enabled consistent, reliable action without requiring individual expertise at every point of execution. Multiplication tables inscribed on clay allowed scribes to perform complex calculations without understanding the underlying mathematics. Measurement conversion tables allowed merchants to conduct trade without being able to independently calculate the conversions themselves. Medical procedure tablets allowed practitioners in distant cities to follow treatment protocols that had been developed and refined by specialists they had never met. Not that the knowledge was abstracted away from the individual and embedded in the system, which is precisely what machine learning models do when they encode patterns from training data into weights and parameters that can be applied by a processor that does not understand the patterns at all. The Sumerian scribe following a multiplication table did not need to understand why it worked. The system worked because the knowledge had been correctly encoded, and that was enough. None of this is to argue that the Sumerians were building computers in the modern sense, or that they had any conception of what we now call artificial intelligence. They were solving practical problems with the tools available to them, and the tools available to them were clay, reeds, outran the collective intelligence of a civilization organized around the production and management of information. But when you examine the functions their systems performed, The comparison is difficult to avoid. They structured data for efficient retrieval. They encoded decision rules for consistent execution. They accumulated observational records and extracted predictive patterns. They abstracted knowledge away from individual experts and embedded it in distributable media that could be copied, taught, and applied at scale. These are not vague analogies to artificial intelligence. These are the foundational operations that define it. What the Sumerians understood, 5,000 years before anyone had a word for it, is that knowledge is not the same thing as understanding. Like, you do not need to understand why a mathematical relationship is true in order to use it correctly. You do not need to understand the astronomical forces driving an eclipse cycle in order to predict when the next one will occur. You need accurate data, a reliable method for processing it, and a system for distributing the outputs to the people who need them. That insight, more than any specific tablet or legal code or astronomical observation, is the legacy of Sumerian information culture. They discovered that intelligence, at least in its functional form, can be separated from consciousness and embedded in a system. And once you have made that discovery, everything that follows, from the printing press to the electronic computer to the large language models of the present day, is a variation on the same theme. But the history of artificial intelligence did not begin in a Silicon Valley research lab in the 20th century. It began in the temples and counting houses of ancient Sumer, where people who had never heard the word algorithm spent their lives building the first ones. If this video gave you a new way of looking at ancient history, subscribing is the best way to stay with us. We release new documentaries regularly, and every one of them is built around the same question. What did civilizations in the ancient world understand that we are only now beginning to fully appreciate? Hit subscribe, and we will see you in the next one.